Hello, my name is Deborah Lowenberg-Ball, and I'm a faculty member at the University of Michigan. And the title of my presentation today is Disrupting Injustice Through Mathematics Teaching, Learning to See, Connect with, and Build Student Resources. I've prepared some handouts and accompanying material for this presentation that you can download from the site, and I'll also be available to answer questions during the live Q&A following my presentation. So I'd like to begin by providing an outline of what we'll be doing in this session. There'll be three things that I'll be taking up. The first is to just spend a few minutes talking about what does it mean to disrupt injustice and why is this so important for students' mathematics learning? The second thing is how can mathematics and teaching practice disrupt patterns of harm and injustice? I'll spend a little time trying to explain the connection. And then finally, the bulk of the presentation will be on this practice of acknowledging competence. So I want to spend a few minutes talking about the disruption of injustice by talking about what is normalized teaching practice. So I'm using the word normalized here to talk about practice that we're all used to seeing every day in school, things that have become normal. That's what the word normalized is referring to. So I have some images on the next couple of slides to remind us all of things we take for granted as rather normal in teaching. So on this slide, you can see a picture of a little boy who's been sent out in the hall, presumably because he did something that was against the rules in his class or did something disruptive. You also see in the lower left-hand corner a very typical math worksheet that we've all seen before, in which children are timed by how fast they can show their fluency with math facts. A couple of other images show children raising their hands quietly to participate in a math discussion. On the upper right, you see a very typical poster that one might see in a lower grade class, reminding students what appropriate behavior is during carpet time. And a lot of math lessons take place during carpet time. You can see children are being encouraged to sit in a particular way, sometimes called crisscross applesauce, looking in a particular direction, keeping their hands in their lap, a lot of control of their bodies. And we know that that's a pattern, actually, particularly for Black and brown children. A couple of other images to remind us about what's normal in math teaching and hence normalized. See a picture again of children working quietly and independently in the upper left. In the next picture over to the right, you see children sitting in individual seats, listening to the teacher who's making a presentation, providing some direct instruction at the board. Below that, you see a girl looking frustrated. We don't really know what's frustrating her. It could be any number of things, including feeling that she's not good at math or feeling that she's just done something that wasn't what she was supposed to be doing or doesn't understand, but she looks somehow definitely not happy about what's happening. And to the left of her, you see a picture of a group of children participating with their teacher on the carpet, doing some math work, but one little boy who's been sent away and is sitting apart from the rest of the group, presumably because he was behaving in a way that wasn't appropriate. So what are some of these features of normalized math teaching? I've listed some of them on this slide. One of them is that math is typically represented as a highly individual activity, and that being good at math is primarily about getting the right answer and often getting it rather quickly and fluently. Another sort of symbol of normalized math activities is a persistent message that some people are good at math and others aren't good at math. And this is often associated with particular identities, racial identities, gender identities, language status, disability status. And there are kind of storylines that go on in classrooms about who's good at math and what being good at math even is. And finally, behavior is also a part of normalized practice about sitting quietly, listening, paying attention. And these are all part of what we've come to take for granted as what it looks like when math teaching is going well. But at the same time, it's important to understand that while it's familiar, it's also even embedded in things that we may not think of as normal practice, but things that we're trying to change. It's called sometimes reform or interventions. We can be fooled into thinking that when we see children as they are in this image, working in a group together and presumably doing something that's a little bit more conceptual and a little bit more both about procedures, but also about concepts, we might not realize that there could be things happening here that are still reinforcing some of those same messages about what it means to be good at math or who's good at math or what appropriate behavior is during a math class. You can see that norms that persist in math classrooms are taken for granted by most of us, and they're often invisible primarily because they are so normal. But they actually cause harm for children, and often the ways that they cause harm aren't even noticed because we're so used to this. We're so used to thinking of math being individual or the importance of children sitting quietly during a class or listening or getting answers right and quickly that we don't even stop to think, what kind of harm is this creating? So I want to show one connection to these kinds of everyday practices and the kind of harms that we can see at a more systemic level. And what I'm going to focus on are what we understand about patterns of discipline practices. So we know that during math lessons, children often may be punished for not sitting correctly or not listening or seeming in some way or another to the teacher to somehow not be engaged or on task. But we also know that there are large systemic patterns about discipline as a function of race. So this slide gives one example of the data that we have through the Civil Rights Office. This shows on the left that, thinking about suspensions in schools, that Black students account for only about 1 in 6 of the children in school. You can see that in the lower left-hand bar. But they account for almost half of the multiple suspensions. And if you study the slide, you can see they also account for disproportionate percentages of other suspensions, like single suspensions or in-school suspensions. Whereas on the right-hand side of the slide, you can see that white children account for almost half of the children enrolled in school, and yet they only account for less than 1/3 of the multiple suspensions. That's what we mean by disproportionality, because you would typically expect that the proportion of children's punishment would be somehow aligned with the percentage of kids in the enrollment of the school, but that's not the case. And in case anyone thinks when they see this that it's because, oh, Black students actually behave worse, that's absolutely not what the data show. What the data show is that these are the product of what you might call discretionary subjective judgments on the part of educators who interpret things that children are doing in differential ways, not necessarily intentionally, but because of the kinds of assumptions and storylines that grow up around us in the society we live in. So for example, interpreting a child as being belligerent or talking back, where another child might just be interpreted as being confident and speaking loudly. And there are many examples that one can find of this. And so the point is that these kinds of things that happen every day in math classrooms are connected to larger systemic patterns. We could also take time to look at how some of the patterns of what it means to be good at math and what being good at math is have similar systemic corollaries when we look at the larger patterns of who enrolls in math, who goes on in math, who sees themselves as good at math. Those also are connected to larger systemic patterns. So in the second part of this presentation, what I want to move to is not talking further about these kinds of harms and patterns that we see through the research, but talking more about what are some of the practices that are possible to do that can interrupt these patterns. So the 3 things that I'd like to mention, but I'm going to focus on just one, are broadening what it means to participate in math classrooms. The second one is reframing what we mean by error, since we know that error is something that fills math classrooms, getting things wrong, making mistakes, having misconceptions. And the third, on which I'll spend most of my time, is a practice called acknowledging competence. So again, in this part of the presentation, what I want to focus on briefly is my argument that mathematics itself and teaching practice can disrupt some of the patterns of normalized practice that I briefly discussed earlier. So let me spend a moment talking about the first 2 before we dig into acknowledging competence. So we won't be able to go into these in detail today, but when we think about disrupting patterns of harm and normalized practice that exclude children from mathematics and often actually exclude them from instruction altogether because of the way they may get treated or punished, there are 3 practices that I decided to highlight today for your consideration of what it can mean to disrupt those patterns. The first is a group of practices and moves that I would call broadening what it means to participate. So we all talk a lot about having children participate in math class, raising the level of participation, but some of the ways that we think about that are limiting. For example, if we only think of participating as whether children talk in class, that limits the various ways that children might participate. So some examples to consider from the research are looking at ways that turns can be distributed by the teacher to include different students making different kinds of contributions during a class lesson, beyond the most typical ones, which are calling on students who volunteer or pulling popsicle sticks or straws out of a box to try to randomize who's being called on. Those are both reasonable things to do, but there are probably 10 to 12 other moves that teachers can make that can broaden who's participating in class. And they include things like making a greater virtue out of listening and understanding listening to be a form of participating. Another is to encourage students to be able to revoice what other students have said. Have they heard what that person said? What is their thought about it? Drawing or showing or writing things, representing things in different ways with diagrams, with notebooks. and collaborating with other students. So again, we won't spend time on this today, but this is one area of work that educators can engage in that can disrupt the kind of patterns that I was talking about earlier. A second big area of work is what I'm calling reframing error. So we talk a great deal about mistakes and misconceptions. Students experience math often as how many problems they get right and what their score is on a test as a function merely of what they get right. I'm certainly not arguing that correct answers are unimportant in mathematics. That would be a foolish thing to say. But reasoning, representing, explaining are also all part of doing well in mathematics. So when you think about error, there are some problems that arise for teachers in trying to move past interpreting everything as either right or wrong. So I'll suggest a couple of them for your consideration. One is that things that we often hear students saying that we might think of as errors or misconceptions can actually be other things than error. One is particularly that students are sometimes answering a different question than the one we think we have asked. So we may think we're asking a clear question, but when we listen closely, we realize the student has interpreted the question to be asking something else, and what they've answered is actually correct. Another kind of thing that happens and can be a little humbling for us as teachers, that students sometimes come up with mathematical ideas that are absolutely correct, that they're actually correct in general, but they're not what we've ever thought about before. And that takes some thinking on one's feet and strong mathematical knowledge for teaching to realize that sometimes what we hear as incorrect is not in fact incorrect. And finally, students are sometimes just making a minor calculation error. Sometimes that matters a lot. That's what we're actually teaching at that moment. But let's say students are working on a complex problem where a small misplacement of a digit in the calculation isn't really the point at that moment. It's more like a bookkeeping error that we might not want to overdo our interpretation of that as a mistake. We all can make those kinds of bookkeeping errors. So it has to do with context and what it is that the student's really doing. And then, of course, the fourth case is that sometimes students are making mistakes or do have misconceptions. Sometimes those misconceptions are a function of things that we've said or that previous teachers or curriculum materials have said that students have taken up and held in ways that we didn't intend. But here, again, I'm suggesting that learning to think differently about our emphasis on correctness and incorrectness could open up a place for being more inclusive in the kind of mathematical skills and competences that students bring to school. So finally, I want to spend the rest of the time talking about a practice that we call acknowledging competence. I'll say here that this practice that I'll be explaining today is drawing from research on complex instruction and from research done originally by Elizabeth Cohen and Rachel Lotan and have been developed further by Rachel Lotan over much of her career. And the way in which we've worked on that in our research is to broaden and to extend those original ideas. So this idea of acknowledging competence, I see here an image of a student who is doing something competent at the board in front of the class. And we're going to try to think a little bit more directly about what does this practice include. I'm going to begin by going to a different body of research than what I mentioned a moment ago, and that is research on positioning theory that really comes out of social psychology. I'm just going to briefly explain this. A seminal piece authored by Bronwyn Davies and Rom Hare can give you more depth on this particular theory. But essentially, it says something that with a lot of words is actually something we probably all understand pretty well. What positioning theory shows us is that the ways in which people talk or react to or respond to things that we do set up how we are seen and interpreted by others. So the way we experience other people talking to us or looking at us or responding to us may shape the way we see ourselves, whether we think we're competent, whether we think we're valued, whether we think we're interesting. And we do the same thing to other people. The way we do or don't look at people, the way we speak to people, the way tone of voice we use can affect deeply their experience of self in that context. It's a very powerful theory. In some ways, while it's quite complex, it's also something we all intuitively realize happens when we have encounters with people that may leave us feeling less than worthy or less than smart. And the point here is how we can deploy this theory in the service of acknowledging students' competence and positioning them as competent and worthwhile and doing good mathematical work. And this is an example of a set of moves that teachers can learn to make that can be very disruptive to the kind of normalized patterns I spoke about earlier. So I want to introduce the main components of the practice of acknowledging competence. And I have some of the references on this slide from which I've drawn some of this work. So basically, the practice involves deploying the power that teachers have to do three things. First, to broaden and label what being competent or smart means. In this case, we're talking about mathematics learning, but you could extend this to talk about other subject areas or even other things in everyday life. So the first part of this is using the power and agency that one has as a teacher to help all the students in the class get a broader idea of what being good at math is. So in some ways, it's a content instruction component. The second thing is that it's crucial to use this power to intervene, to reposition who's seen as smart in the class or competent and what is seen as competent. And here I'm using the words competence and smart to think about things that people do, not traits of those people. So what does it look like to do something smart in math class? How do we broaden what students think that is? And how do we broaden students' ideas about who is doing those things in class? And the point here is to intervene on patterns that often recur about who's often seen as smart in math class or what is often seen as competent. And finally, it can also be used to support the development of individual students' positive self-identities, their sense of worth, their sense of competence, and so on. So sometimes it's a practice that might be used simply in a one-on-one context. So sounds good so far, but it actually requires quite a lot of knowledge and skill on the part of educators. So let me talk about that for a moment. So acknowledging competence requires three things. First of all, one has to have a pretty broad understanding of the domain or the content oneself, because you can't actually broaden how students are understanding what it means to be good at math or what math is unless you yourself have broader or increasingly broad ideas of what mathematics is. The second is using this concept of positioning to intervene, to influence who and what is seen as competent in that context. So you're trying to deliberately reposition students out of the ways that they typically may see themselves or others may see them. And here's the hardest one that's hard to talk about in a presentation like this. One has to make these moves of intervening, which we'll be looking at in a few minutes, in ways that are authentic and actually have value to the students in your classroom. So the way that one might do that in a kindergarten class, the kind of thing one might say to whom one might say it, might look very different than the way that would be a good way to do it with middle schoolers. And that's something for which your own judgment is going to play an important role, because not all moves would be well received or have the effect that you hope. So to practice this idea and to ground it, we're going to watch a video now. I want to explain what the mathematics task is that the students are working on in the video. It's a fractions problem kind of near the beginning of students' work on area models. And you can see in this diagram that the two rectangles on the slide, both are divided into three regions, and they both have one region shaded gray. And in fact, if you look closely, you can see that the two gray shaded regions are both the same size and shape. So the problem is designed on purpose to confront students with the notion that when one looks at area models, one has to identify the whole, and then one has to divide the whole into equal parts and then determine what part is shaded. And this, I will point out, is different for children than when they may have been working with sets and fractions. So for example, if you have a set of cookies and 10 of them are chocolate chip and 2 of them are oatmeal, you don't measure them to see which ones are, what fraction of the whole are chocolate chip. You simply count. But with area models, you're interested in the area and the actual size and shape of the area. So that's a distinction that the students are confronting pretty much near the beginning of their understanding of area models. So in the video, we're going to see 6 children: Antar, Gabrielle, Gabby, Vershawn, Marquise, and Cassie. And I invite you, while we play the video, to be focused on these 3 questions. What kinds of competence do you notice any of these children exhibiting or displaying? What competences do you think are being acknowledged, and whose competence is acknowledged, and how do you see it being acknowledged? And do you see any missed opportunities to acknowledge competence? What's the competence, who displays it, and what is important about it? One of the resources that I'll be posting is a transcript for this video that you may want to view at some other time if you choose to review the video. So again, you'll be watching these 6 children, who are the children who speak during the class, and you're going to be looking at these 3 questions. Who'd like to answer what you think about the second rectangle? We're only going to be able to talk about this briefly. We probably won't finish it. Who'd like to explain what you think? Antar, what do you think? Could you come up to the board and explain? Thank you. I really like the way the people who are coming to the board are doing today. You're explaining really well. Here's a marker. Can you explain your thinking?
I think it's not a fraction because all of the parts are not equally the same shape.
Can you say that one more time to the class?
I think it's not a fraction because all the parts are not equally the same.
Can someone repeat what Antar said? Very nice, Antar. What did he say? Gabriella?
He said that he doesn't think it's a fraction because not all the parts are equal.
Is that what you said? Okay, would someone like to comment on that, agree or disagree with him? Okay, let's see. How about Gabby?
I disagree.
What do you think?
I think the fraction is 1/4.
1/4? Do you want to come up and say why you think it's 1/4? Antar, do you want to stay there? Do you want to sit down? Okay, thank you very much. You did a good job of explaining your thinking. So let's hear what Gabby's thinking.
I think it's 1/4 because, like he said, all the fractions aren't the same, but you can make them the same by dividing a line down the middle.
Can you go ahead and want to show us here? Here's something you can use for that. Wait 1 second. Instead of drawing it, why don't you just use this? That way if someone wants to take it off again, they can. Okay, so now explain what you've done. Talk to the class, okay?
I divided it down the middle because since it's not equal, you have to make it equal.
And so then you decided?
It's 1/4.
Okay, can someone repeat what Gabby said, what she did and what she said? This actually goes very nicely with what you said, Antar, because Antar noticed that the parts weren't equal, and what Gabby is doing has to do with equal parts. So these two answers go together very nicely. Can someone repeat what she said? How about Vershawn? What did she say? You didn't know? Do you want her to say it one more time and will you follow it? Okay, say it one more time.
You have to make the fraction the same since it's not equal, and you have to divide it by a part where it's going to be equal.
Now, can you explain what she said? You want someone else to try? Okay, but follow, okay? Because I want you to be able to follow when other people explain, all right? So who would like to explain what she just said? How about Marquise? Can you do it? What did Gabby say? Can you stand where he can see? He can't probably see so well. What did she do to the second problem?
She added a line to make it. She added a line to make it 2 more.
To make it what?
To make it like this whole piece 2 more pieces. So I can actually.
And why did she do that? Can you say why did you add the line?
Equal.
Can you say that again, Marquise? Why did she add the line?
So I can make 4.
What word did Gabby just say that you need to say? She said she didn't just make 4 parts. She made what kind of parts? Say it again. Equal parts. The same size. Do you see that, Marquise?
Yeah.
Okay. So, and she came up with 1/4. Cassie?
Well, I just wanted to say I disagree.
You disagree with her? Okay.
I disagree because the question was asking what fraction of the rectangle is shaded gray already before you add the line. And my answer for it was 1 1/2. Because you might say it's 3 1/3, but he's right, it's not equal. So
that was Antar. Antar's right.
Antar said it's not equal. So but there's 1/2 below, like a full rectangle.
Here, we can take the line back off for a minute. Gabby, I think you can sit down. I think you did a nice job of explaining. I can take this line back off. So what are you saying now?
There's the part that is shaded would have to be 1/2 because below there is it's cut up into a half.
This right here?
One above it.
Okay, so we're going to stop there. It's just about lunchtime in this classroom, and they don't continue discussing it. The teacher concludes by saying, this is very interesting, and we'll return to it tomorrow, where Cassie can explain more of what she's saying. So I want to move on now and talk for a moment about, before we talk more about acknowledging competence, distinguish it from something else that's a very common practice, which is praise. And I want to be clear that the point here isn't to say that praise is bad and acknowledging competence is good, but that they're different. So to distinguish them, on the left, you can see some examples of things that teachers might say that are perfectly worthwhile, like saying you're working well today, or nice work, or I'm proud of you. But on the right are examples of what we're going to focus on here, which is acknowledging competence. And the difference is that praise is basically verbal feedback with the purpose of evaluating in some way what a student has done, whereas acknowledging competence is intentionally identifying, naming, and highlighting specific mathematical or learning competencies of what a student has done or said. So you can see some examples on the right, like it was particularly clear how you used your drawing to explain your thinking, or saying it is clear how closely you're following other people's thinking and connecting it to the idea that you had. Or you could say to the class, one thing that was really important about what a student said was to use the definition that we developed. So you can see that the difference is that acknowledging competence is deliberately focusing on a very specific aspect of mathematics and mathematical competence as a means of lifting up something and highlighting something that a student has done that's competent. So when you think about acknowledging competence, some of the things one might consider are examples of mathematics learning and what you might say to acknowledge competence. So some things students might be doing is presenting their ideas to others, as we saw in the video, using a representation skillfully, as we saw in the video, asking a good question, showing a solution, explaining one's reasoning, and there are more, but one has to broaden one's sense of what mathematical competence is in order to be well positioned to do this as a practice in teaching. So I want to say a little bit about why acknowledging competence is a disruptive practice. It disrupts patterns that are narrow and reductive views of math. It disrupts who is often seen as mathematically competent, which is often racially and gendered patterned. And it disrupts negative and deficit views students may carry of themselves. So what's involved is being able to recognize and broaden conceptions of what comprises mathematics and mathematical competence, and seeing that in the children, and then understanding the broader factors that affect children in our classes, particularly Black and Brown children and children with disabilities, children who are English learners. Those are larger patterns that also influence how children are seen. And you're working to intervene explicitly to acknowledge particular students' competence genuinely. So some things one can do are to name specific competence that a student did, or you could ask the class something that a student did, and remember that it's about broadening what counts as mathematical competence in a genuine way, not a gratuitous way, and also intervening on who's seen that way. So if you think about the 6 children in the video, you could consider what competencies you would acknowledge and whom you would choose to acknowledge and what you'd actually say. So I'll just conclude by sharing a slide of some examples of what one might say to any of the children on the video. And to show things like, for example, Marquise, who kept being told he should say the word equal when in fact he was doing something very competent by taking notes in his notebook and sharing it with the whole class. There are some habits that teachers will have to break in acknowledging competence, like tending to orient the comment to oneself, like you helped me see your thinking, instead of doing it in a way that the whole class is seeing what the teacher is saying about the student. Thanking the student, like saying thank you for sharing your idea instead of highlighting the mathematics. Still correcting somehow at the same time, like saying, but remember, we're really talking about the whole, instead of authentically naming the mathematical contribution, and saying things like good job instead of being specific. So again, to conclude, it's going to be important as you try this out to think about what will be valued with your students in your context and not inadvertently do other kinds of harm. What would land on your students in ways that could reinforce instead of disrupting patterns of racism and other forms of oppression, and what are things that could disrupt that? And with that, I'll close, and I hope that this has been useful. Thank you. I see a question about how people might start to do this kind of work. I think one of the first steps is to be able to, first of all, understand the purposes of this practice and some of the basics that I explained in the presentation. But I think in order to start learning how to do it, it probably starts with being able to see the strengths of students. I also think that what I've noticed is that people can take up this practice and not take up the part that has to do with disrupting status hierarchies. Some people can begin thinking about strengths of students and thinking of things they could say, but the complexity of also thinking about how students are positioned both in one's own classroom and larger patterns of how students with particular identities are positioned, that takes extra work to combine that. So what I mean by that is that we know that, for example, Black and brown students are very likely often to be seen as struggling or perhaps to be interpreted as behaving in ways that don't conform to the norms of the classroom. And so a teacher would have to understand both the larger patterns that impact students' lives and experiences, as well as things that are happening in their own classroom, and be very strategic about whom they're making a decision to acknowledge competence. I see a question about how to help teachers who've been successful in a system that values correctness and speed learn to reframe their classrooms to value math differently. That's a really good question. And I think some of that work requires being very explicit and surfacing the way in which mathematics has functioned to reproduce inequalities and hierarchies that favor particular groups, white people, Asian people, males. They have to see that, and they may not have recognized that before. There was a question about Cassie's reasoning, who is at the end of the video, and I do want to comment on that because I think that when people watch this video, teacher candidates or teachers, they might need support to understand that Cassie is actually saying something that's very mathematically sensible and deserves to be highlighted as having interpreted the problem in a way that's sensible, since the point of the problem is to be thinking about what constitutes the whole. Cassie is seeing a different whole, and she's seeing the upper half as the whole, and therefore the bottom, she's seeing one plus a half. But often people perceive Cassie as making an error. So this is part of the acknowledging competence work, is being able to actually see the mathematical validity of what students are bringing up. And this intersects what I was saying earlier about error. There's a question about students thinking about and working with visuals. And thinking about the use of visuals as it relates to multilingual learners. So I think that that is an important thing too, that there are multiple modalities for the ways in which students are accessing the content and having opportunities to reason about it. There was a question about math identity and racial identity. I apologize, I'm not getting to all the questions. I do see them, but it's hard to answer in this format. I think it's right that teachers have work to do on the concept of math identity and racial identity, and quite a few people in the field are doing excellent work on this right now. That is really important. I think it's important that as we do that work with them, they link that to how they're showing up in classrooms and the ways in which their discretionary judgments are influencing the way that they're seeing their students and their ability to see the strengths of students and be able to lift up their competence. I don't know that there's a good way for me to comment on the relationship of this to the work of Peter Liljedahl on building thinking classrooms, but maybe some of you who have worked more deeply on that work, which I am familiar with, than I have, might be able to build those connections. I see this work as being combining direct work to combat racist and sexist and other kinds of marginalizing patterns and serious work on mathematics and children's thinking and the ways that you can reposition and use teaching to use power to reposition students' sense of themselves and the way they're positioned relative to others. There was a question that asked about how to help new teachers who are well-meaning but are trying to navigate new understandings. I think it takes time. I think this is a complex bundle of practices to learn, or a practice, if you will, because it combines so many different aspects of identity, mathematical knowledge for teaching, awareness and consciousness about race and gender and other marginalizing identities. But it takes deliberate work with lots of practice and feedback.